Okay, so now that we've made our diagram from the information that we have in the question, we've decoded everything that's in the worded question and put it onto paper, we're ready to move on to the next part, which is filling in the blanks. Now, filling in the blanks is using the information that we have from the question already and perhaps getting some more information that isn't explicitly stated in the question. So for an example, I've already got this written in here, but my right angle at the base of my lighthouse, it's very rare to get a lighthouse, especially in a maths question that is not at 90 degrees to the ground. So that 90-degree angle you could probably put onto any building in any maths question. It's always going to be at 90 degrees to the ground. So lo and behold, now I've got two triangles that have a 90-degree angle. That means there's a good news because I can use trigonometry now. Now, for the sake of communication, I'm going to name the top of my lighthouse. I'm going to name P, and the bottom of my lighthouse I'm going to name L. So I'm just giving names to those points so I can start talking about different triangles that we have. So I've got three triangles, but I've got two right angle triangles here. One, triangle A, or triangle APL, goes from this point here up to P and down to L and then across again. And the other triangle that I have is triangle BPL, which is slightly different because it starts here at B. Now that I've got those triangles sorted out, I need to think about what else I can add into this because neither of these triangles actually have any angles in them. So I need to figure out how I can use these angles of depression and apply them to the triangle that I'm trying to use. So if I look, an easy way to do this, and the way that I like to do it, not necessarily the right way, but the way I like to do it, is I like to think about these lines, so B, and I kind of do a dotted line at either end. Okay, so I extend those lines out. Now, if you think back to year 7 maths, you've got two parallel lines, okay, and I've got a line going through it at any angle. I know that this angle here is always going to equal the opposite. This angle here is always going to equal the opposite. Now, these are called corresponding angles. I also know that this angle down here is going to equal the same as the angle up here. And these angles here are going to equal the same as the angles here. Now, knowing that information, I'm going to apply that to triangle APL. I'm going to draw these lines out a little bit. And I know that this side is 28 degrees and 40 minutes, so that means across my line, between my line of sight and the extension of this is also 28 degrees and 40 minutes. Now, if I apply that down here, that means that this angle here is 28 degrees, 40 minutes, and angle A is 28 degrees and 40 minutes. Okay, that's really helpful, isn't it? So angle A is equal to 28 degrees and 40 minutes. Now, if I rub this out and then apply that same thing to triangle BPL, I know that this is 46 degrees and 25 minutes, so this here has to equal the same, which means that this here also has to equal 46 degrees and 25 minutes, and this angle here also has to equal 46 degrees and 25 minutes. Okay, now I've got two triangles with two separate angles. The only thing I'm missing now is a little bit of communication, and I'm just going to rub this out because it's useful for finding the angle. But you can see I've named the distance between A and B. I've named that X. I'm also going to need to find, I can't find X by itself with one maths equation, okay? We know now I've got an angle and a side, so I can use SOHCAHTOA now. We know that. But I'm just going to, for ease of communication, I'm going to set this out as so. So from B to L, now I know I've left a gap here, but that should be from B to L. We're going to call that Y. And from A to L, we're going to call that Z. Okay, so A to B is X, B to L is Y, all of it together is Z, and I've forgotten to draw in my angle, so angle B is equal to 46 degrees and 25 minutes.